Welcome to this video on SAP Business One UI API Fundamentals. Here, we'll master the interface layer that powers SAP Business One's user experience through screen interaction, form manipulation, and event handling. What exactly is the UI API? It forms the interface layer of SAP Business One, allowing developers to interact directly with the user interface. Its key purpose is to control and manipulate the visual interface that users work with daily. It focuses on-screen elements, forms, menus, and user interactions. Understanding the distinction between UI API and DI API is fundamental. UI API focuses on screen interaction, enabling you to manipulate forms and handle user events. DI API, the Data Interface API, focuses on database interaction, handling queries and updates. A good analogy: UI API is the steering wheel and dashboard, while DI API is the engine and transmission. The UI API architecture is hierarchical. It starts with the application object, the entry point to SAP Business One. This leads to the Forms collection, which manages windows and screens. Within Forms, you find items, which are your controls and fields. Finally, the event-driven model allows you to respond to user actions. This structure provides granular control over the interface. The application object is the central hub for all UI operations and the foundation of every UI API interaction. Common uses include displaying status messages, managing open forms, and subscribing to application-wide events. Remember, the application object must be obtained from the SBO GUI API connection before any UI operations can be performed. To connect to the SAP B1 UI API, you follow a simple process. First, create an SBO GUI API instance. Then, get the connection string, typically from command line arguments. Next, call the connect method to establish the connection. Finally, get the application object and verify the connection. Remember, hard-coding credentials is not recommended. Forms represent the windows and screens users interact with. Documents, master data screens, and report windows are all form objects. Examples include the sales order form and the business partner form. Access all currently open forms through the application object's forms collection. The forms collection offers two main ways to access forms: the active form and a specific form. Active form accesses the currently focused window, useful for event-driven scenarios. Specific form allows you to target a form by its type, like 139 for sales order, and instance index, which is useful for batch operations. To connect to a specific form, you use the getForm method, specifying the form type EX parameter and the index parameter. Form type EX is a unique identifier, like 139 for sales order. The index parameter specifies the instance. 0 is the first, and -1 is the last opened instance. Use app.forms.count to check open instances first. The UI API implementation follows a four-step pattern: connect to application, access form, access items, and handle events. This process allows you to establish a connection, find the form, navigate to specific UI elements, and respond to user actions. In Part 2, we will focus on accessing and manipulating UI elements. Welcome to Part 2 of SAP B1 UI API Fundamentals. This part is dedicated to mastering the essential UI elements and controls for building custom functionality in SAP Business One. We will cover how to manipulate forms, handle user input, and manage data effectively. SAP Business One provides a comprehensive set of built-in UI controls. These include EditText controls for data entry, buttons for triggering actions, combo boxes for predefined list options, matrices for tabular data, and static text for labels and read-only displays. Each element has a specific role in form design. The items collection is your gateway to controls on a form. Each UI element has a unique item UID that you use to retrieve it. Once you have the item reference, you must cast it to its specific type to access control-specific properties and methods. EditText controls are essential for data entry. To retrieve the control, you access the form's items collection by item UID, cast it to sapbui.com.editText, and use the specific property. You can read values using the value property, and set values by assigning a new string to it. Buttons trigger actions like add, update, or custom logic. Retrieve a button by its item UID and cast it to sapbui.com.button. Although you cannot directly read the button state, you can enable, disable, or handle its click events. Common uses include saving data, launching secondary forms, or executing workflows. ComboBox controls offer predefined options, ensuring data integrity. To work with a combo box, you access it via the item UID, cast it, and use the specific property. You can select a value using the select method with the search key, and read the currently selected value using the selected.value property. You can dynamically populate combo boxes using the valid values collection. The add method takes two parameters: the stored value, which goes to the database, and the description, which the user sees. This is flexible, especially when options depend on business logic. Matrix controls display data in rows and columns, similar to spreadsheets, and are vital for transaction documents. They support dynamic rows and multiple column control types, such as EditText and ComboBox, making them highly versatile for multi-line data entry. Accessing matrix data follows a three-level hierarchy: matrix, columns, cells, and finally, the specific control. You must first get the matrix object, then target a specific column by its unique ID. Next, locate the desired cell by row index, and finally cast it to the specific control type to access its properties. Reading and writing matrix data requires casting the cell's specific property to the correct control type, such as EditText, before accessing its value property. This casting pattern ensures type safety for both reading an item code and setting a new value. Welcome to Part 3, focusing on event-driven programming and UI extension. We will explore how to make your add-ons responsive by handling user actions, intercepting menu commands, and controlling data operations. The UI API utilizes an event-driven architecture. Your code waits for user actions, such as clicks or data entry, which trigger specific events. These events execute corresponding logic, allowing you to extend SAP Business One without altering its core code. The UI API provides three core event types. ItemEvent handles interactions with form elements, like buttons and fields. MenuEvent responds to all menu selections. FormDataEvent controls data operations like adding or updating records, enabling validation before database submission. To handle a button click using ItemEvent, first subscribe your handler to the application event. Inside the handler, check the event type, identify the item UID, and execute your custom logic. The BubbleEvent parameter determines if SAP's default action proceeds. MenuEvent allows you to intercept standard commands like add or find. After subscribing the handler, filter by the specific menu UID to identify the command. For instance, menu UID 1282 corresponds to the add mode. You can then execute custom logic and maintain universal menu handlers. The FormDataEvent provides control over record operations, firing both before and after the database action. The before action phase is crucial for validation and modification, while the "after action phase" can be used for follow-up logic or notifications. Event bubbling is the process where an event travels through the application layers. Crucially, the BubbleEvent parameter controls this propagation. Setting it to false stops SAP's default behavior, which is essential for validation, or blocking actions like saving or deleting records. Setting BubbleEvent to false prevents standard SAP functions from executing, enabling mandatory field validation or blocking unauthorized deletion. Setting it to true allows SAP's default action to proceed after your custom logic has run, which is suitable for logging or supplementary updates. To extend the UI, you can add custom menu items using the Menu Creation Params object. First, access the menus collection and identify the parent menu, like Tools. Next, create the Menu Creation Params, defining the unique ID and title. Finally, add the menu and handle its selection using the MenuEvent. The complete development flow involves 5 steps: connecting to the UI API, accessing the form, working with items, handling events using the 3 core types, and extending the interface with custom menus and buttons. This comprehensive approach allows for robust add-on creation. Next, we will cover custom forms. So in this video, we covered the complete fundamentals of SAP Business One UI API, the interface layer. We understood how to work with the application object, how to access and interact with forms, and how to handle built-in UI elements like EditText, button, ComboBox, and matrix. We also explored one of the most important concepts in real development, event handling, including ItemEvent, MenuEvent, and FormDataEvent, along with event bubbling and how BubbleEvent gives you control over SAP's default behavior. And finally, we learned how to extend SAP Business One by adding custom menus and toolbar buttons. Right finger. Now you have a strong foundation to start real UI-based development in SAP Business One. Rock it! In the next video, we'll move into something very important and practical. Right finger. How to make your first connection to SAP Business One. Right finger and start building your first working add-on step by step. We'll go from theory to real implementation. If you found this helpful, don't forget to like, share, and subscribe. And I'll see you in the next video, where we actually connect to SAP and start building. Let's move from learning to doing.